Hello and welcome back to the lecture of time series econometrics. This is a continuation of the lecture on random walk. This is part 2. Previously, we spoke about random walk and we gave you example of Brownian motion. We gave you example of a drunk man walking. And we asked you if I can see or I know the position of a red ball in a Brownian motion or the step of a drunk man at tth time, can I say something about the position of the red ball or the step of the drunk man at t plus 1th time? Okay, and we said that we cannot, right? And we explained the value of the y in terms of the error term. So we showed how we can use the error terms to actually construct a model that would explain the mean and the variance of the random walk, right? And how we did that, just to recap, we wrote we wrote yt as a sum of ei, where I is basically 1 to t, right? And we wrote expectation of yt is equal to expectation of the whole thing, which is nothing but 0, right? Which is equal to 0. And we also got the variance of the yt is equal to t sigma square, where t is the time period, the number of time period that we are considering. So what you see is this is a random walk model, basic random walk model without drift, with a mean value 0 and a variance t sigma square. Okay. Now we will try to see what are the other sort of varieties of random walk model we can think of. Okay. We will ask you some questions after this. Um, we will see how these different models vary, what is the relationship, whether they're stationary, non-stationary. But before that, let me explain the other model of random walk. Now, a random walk with a drift. So let me write down, this model is random walk with a drift. A random walk model with a drift, when we construct a random walk model with a drift, what we do is we actually write yt is equal to, we actually take a drift parameter, we call it drift parameter, alpha plus yt minus 1, and say the error term for the tth period is epsilon t. Okay. In a similar manner, the way we actually created the series for random walk without a drift, here also we can actually create the series for random walk with a drift. Okay, and how I will write it is the same, alpha is alpha, yt minus 1, I will write it as alpha plus yt minus 2 plus epsilon t minus 1, because this is for the t minus 1th period and I already have epsilon t, so which means I have 2 alpha yt minus 2 epsilon t minus 1 plus epsilon t, right? Similarly, if I keep on extending it, I will get 2 alpha. Here I will break it down into alpha plus yt minus 3 plus epsilon t minus 2. I'm pretty much constant by the space, but let me just write it down. Et minus 1 plus et, and I'll use another page where I can write that essentially yt would mean, if I do that, for the tth period I will have alpha t plus y0, let us have plus epsilon. Basically I can write sum total of I equal to 1 to t epsilon t. Okay, now similarly if I just take a the mean, the expectation of yt here for the drift, for the random walk, so what I will have is expectation of the whole thing, right? E of alpha t plus y0, y0 plus summation of I equal to 1 to t epsilon t. Okay, which would mean, now what happens to the expectation of alpha t is basically alpha t, because that's constant. Now y0, we can consider that the value at t equal to 0 equal to 0. That's an assumption, but you can safely do that for the model building purpose, and you take this expectation of summation of, oh, this should have been I. This is I, okay, not this. Summation of EI, I equal to 1 to t, which will mean is basically 0. So what I'll have expectation is alpha t. Now I will also do the variance of yt. V of yt is equal to V of alpha t plus y0 plus y, second, y0 plus summation of ei. Okay, I'm not writing, or I can write I equal to 1 to t. Okay, now what will happen? Now this one is a constant V of alpha t, so there is no variance, basically 0. This one is also 0, so the model, and this one V of expect I equal to 1 to t. Now since the error terms are IID, I will have this equal to alpha square, sigma square, and sigma square. So note that this variance for the random walk with a drift and the variance for, let me show you the other document, the variance of random walk without a drift are basically same. In both the cases I have variance t sigma square, right? In both the cases I have variance t sigma square. Whereas for random walk without a drift I have mean equal to 0, and random walk with a drift I have the random, just a second, the random walk with a drift I have mean equal to alpha t, right? So the two things, you can see that there are differences in mean, but the variances are same. Now in this context I need to explain something. I will just explain the next lecture how we can actually interpret these results in terms of the stationarity. But before that, let me just conclude this lecture by saying that the alpha thing is basically the parameter here. So basically what you see here, you actually see a trend here. When you have a random walk with a drift, you actually see a trend, alpha t, okay? And remember that in both the cases, the error terms that we are using, all the error terms are basically white noise, and all the error terms are basically IID, okay? So these two series of IIDs are creating two white noise series. One is with a drift and another is without a drift. Okay. Okay. So in the next lecture, we are going to see if the random walk process is actually stationary or not. Okay. Thank you.